Today I'll be demoing my DesignBuilder tool, which can read a system design document, parse out the content, extract out the components of the system architecture, and spin up parallel coding agents to build each component. So here it's available in CLI version. It's got 4 commands: a build command to parse the design document, spawn coding agents and build out components, agent status to view the progress of the running agents, agent logs to view the logs of a specific agent, and a guide command to interactively debug and guide a failing agent. So I have a simple design here with a web server design. And so it has 4 components: an HTTP server, a router, a handler, and a logger. So here, I'll show you a demo now. So I've implemented it and you can see the agents running. And so they're in the implementing phase here, and the underlying LLM used is Gemini 2.5 Flash. And there's 4 agents running to build out each of the 4 components: HTTP server, router, handler, and logger. So I've built this to, another thing to note here, and then it goes into the writing test phase, writing unit tests for that component. And we can go back to the logs here. Generate code written to DesignBuilder output / classes / handler. So close this up a bit. So it looks like, let's look at the handler code. Source handler, base API handler, business logic. So some potentially useful code here. And so what phase it's in. So it looks like the handler actually paused for guidance. So how it works is it will run a test debug cycle where test is running the test and debugging it, making a call to an LLM to debug the implementation code, but it'll do that for 10 cycles, and then it'll pause for guidance from an engineer. So it keeps it a human in the loop. Really encourages that. And so let's look at some of the test handler code here. Looks like it has some issues, but it's still potentially some useful code for testing the implementation of our handler. And let's see what else we have here. So that one's paused for guidance. Cool. Now, same thing for router. It's also paused for guidance. So let's look at that file, those files. So this looks okay. That's useful. Route request, add route request, test router. It's importing the class, but that's pretty fixable. We can cut that code out and import it. Test router initialization, private method. It's a little too much code here, but we can cut things out. Request, potentially some useful testing though. And same thing for HTTP server. So 36 tests have actually passed for the HTTP server component, and 17 have failed. So here's the actual code. Built up the classes, we can import those. Response, hand client, start, stop server as defined. Our doc, start, stop. Then let's look at the test HTTP server code and cut that code out. We actually wrote the class code in there, but we can cut that out. And yeah, it looks like it's got some potentially good tests. So let's go back here. So other one, the logger is also paused for guidance. Looks like, yeah. Review logs and code for debugging. Yeah, so the logger here too. We got here central logger, file rotation, implementation that's potentially useful. Same thing here to cut out the actual class, but testing the central logger here. Yeah, so this, we have some potentially useful code done in maybe around 5 minutes to spin up all 4 components of our architecture. So this can definitely speed up the software development process for senior engineers and other engineers who have their system design docs ready. So another thing, I'll explain the architecture of this design builder tool itself. So how it works is it will check, given I passed in this design2 doc, it will take a hash of the content of this design2 MD markdown file, and it will check if that hash already exists in the plan cache. If it does, it won't extract out the content from the document, parse out the components, and then generate a plan with the LLM again. So by doing that, we're reducing unnecessary LLM calls, and by using this persistent memory, in a way, it sort of simulates long-term memory, where by writing to this file, it's stored in our long-term memory, and we can use that same plan with time generating it to implement, test, debug our component, and try to build it out. So I did it in this way because of based on the rate limits of Gemini's 2.5 flash model. I was going past the requests per minute rate limit when I was parallelizing the planning step 2 with parallel agent. So I decided to do one central plan, given that was far under the tokens per minute rate limit. So so much more tokens I can pass into a context window. So I made the planning step happen in just one LLM call instead of parallel steps. But so again, yeah. So again, to reiterate, so this tool can extract out the content from a design doc, spin up parallel coding agent to build out the components, and hopefully can speed up the software development process for engineers.